Hello students, today we are going to consider the composition of two S.H.M.s. In the beginning of the chapter Oscillations, we have studied one experimental arrangement of spring mass oscillator. On that, on a horizontal straight line path, the oscillator moves to and fro about the mean position O. Extreme position we have denoted by M and N. At a time, single force is applied on the block so that the spring is stretched, then released, and we have observed to and fro motion of the block. At a certain position, say P, if the displacement is x, then related restoring force is F. So we have shown F is equal to minus kx. So single applied force is there. Now we have to apply two forces at a time. Means the block is subjected to two different forces at a time. So first we consider here that in the first step, suppose one force is applied so that the restoring force is F1. It produces the displacement x1 in time say 3 seconds. If another applied force is there in the second step and it produces the displacement x2, again in the same time we have noted the displacement x2. So these two forces we have observed by the application of two different forces, say F1 and F2. Now if simultaneously both the forces are applied on the block so that the spring is stretched and the new restoring force, it may be F1 plus F2, and it produces the displacement x. So this is new displacement or resultant displacement, and this resultant displacement can be here equal to x1 plus x2, and it is the vector sum. Resultant displacement due to the application of two forces simultaneously produces two displacements, and resultant is vector sum of two displacements. Here we again summarize this point that instead of applying a single force, if the particle is subjected to two different forces at a time on the same particle, then it performs linear S.H.M. or it performs S.H.M. and its resultant displacement is equal to vector sum of two displacements. Now we have to obtain the relation for the displacement, related initial phases, amplitudes, but for the study in our scope of syllabus is related to the S.H.M. which occurs on the same path. This is our first condition. There are so many conditions to obtain such resultant S.H.M., but we have to consider one simple relationship for the combination or composition of two S.H.M.s. So first condition is same path, same angular frequency, and third that the two S.H.M.s we can use of two different amplitudes. Here two different amplitudes and different phases, different initial phases. So if we consider such conditions, then the composition becomes simple. So we have to consider the simple composition of two S.H.M.s instead of taking the complicated compositions. So here we consider two displacements. Consider two displacements which occur when the particle is subjected to two forces. So first displacement is x1 is equal to a1 sin omega t plus phi 1. This is equation number 1. Second displacement by the application of second force alone is a2 sin omega t plus phi 2. This is equation 2. You have to note that amplitudes are different, a1, a2, different amplitudes. Phi 1, phi 2 are different, means different initial phases. Omega is same omega, same period, same frequency. And x1 and x2 are taken, which indicate that the displacements are along the same path. Now, the next points or subsequent steps are mathematical. How can we write? X is equal to sum of two displacements x1 plus x2 can be a1 sin omega t plus phi 1 plus a2 sin omega t plus phi 2. This first term, first sign can be expanded by considering the relation sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta in this way. How can we expand it? A1 sin omega t cos phi 1 plus A1 cos omega t sin phi 1. This is for the first sin omega t plus phi 1. A1 multiplying factor. Next bracket A2 sin omega t cos phi 2 plus A2 cos omega t sin phi 2. Next step is also very simple. Here we take sin omega t as common and write the first and third term combining here a1 cos phi 1 plus a2 cos phi 2 multiplied by sin omega t. Now we add second and fourth term cos omega t as common. Cos omega t as common, and here it is a1 sin phi 1, a1 sin phi 1 plus a2 sin phi 2. Now here for this first bracket we substitute the term r cos delta. Cos functions are, cos ratios are there. Now a1 cos phi 1 plus a2 cos phi 2, this bracket we can substitute as r cos delta. So for this first term we write r cos delta for this bracket multiplied by sin omega t plus for the second bracket a1 sin phi 1 plus a2 sin phi 2 we substitute as r sin delta. Here r sin delta, and multiplied by cos omega t. It can be written as r inside the bracket sin omega t cos delta plus cos omega t sin delta, and now you can easily take it as is equal to r sin omega t plus delta. So this is x. So here the numbers to the equation must be given for the sake of next further calculations. Here x is equal to x1 plus x2, and this step we can take it as equation number 4. So this is the equation of resultant displacements when the particle or body is subjected to two different forces. Now x is in terms of capital R and delta, but this R and delta are related with A1 phi1, A2 phi2. So we have to find out the relation for R by considering these 2 points. These 2 equations can be denoted by A and B. How can we take it? So here the step is like this: squaring and adding equation A and equation B. So we have to square A and square B. How can we take the first square LHS and RHS? So we can write addition directly because we have to add also. So R square cos square delta plus R square sin square delta. This is the LHS. Now RHS also square A1 cos phi 1 plus A2 cos phi 2 square plus A1 sin phi 1 plus A2 sin phi 2 and this whole square. Now on the LHS we write R square cos square delta plus R square sin square delta is equal to R square. Now here expanding this first bracket we get A1 square cos square phi 1 plus A2 square cos square phi 2 plus twice A1 A2 cos phi 1 cos phi 2. So we adjust it here like this: cos square phi 1 plus A2 square cos square phi 2 plus twice A1 A2 cos phi 1 cos phi 2 plus second bracket expansion we get A1 square sin square phi 1 plus A2 square sin square phi 2 plus twice A1 A2 sin phi 1 sin phi 2. RHS LHS is R square. It is equal to, we take A1 square cos square phi 1, A1 square sin square phi 1. These two terms addition gives us A1 square. Inside the bracket cos square phi 1 plus sin square phi 1, it is 1. Similarly for this second and fifth term we get A2 square common, cos square phi 2 plus sin square phi 2 is 1 plus For the third and sixth term, twice a1, a2 common. And we get inside the bracket cos phi 1 cos phi 2 plus sin phi 1 sin phi 2. We get r square is equal to a1 square plus a2 square plus twice a1 a2 twice a1 a2, and bracket we get as cos phi 1 minus phi 2, cos phi 1 minus phi 2. This cos phi 1 minus phi 2, its expansion is cos phi 1 cos phi 2 plus sin phi 1 sin phi 2. So this is the relation for amplitude. It can be written here. We take the step here. R square is equal to a1 square plus a2 square plus twice a1 a2 cos phi 1 minus phi 2. Here written it as like this, and its number we give it as equation. Say we use that number. Here we write r is equal to under root a1 square plus a2 square plus twice a1 a2 cos phi 1 minus phi 2, cos phi 1 minus phi 2. This one is equation number 5. So in the relation x is equal to r sin omega t plus delta, r can be obtained by using the expression 5. By substituting values of a1, a2, phi 1, phi 2, we can obtain the value of r. So this is the resultant amplitude of the combination of two S.H.M.s. Now we have to obtain for delta. For the determination of delta also we have to use equation A and equation B. How can we use it? So here divide equation B by equation A. So dividing equation B by equation A, we get r sin delta upon r cos delta LHS is equal to a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi 2. Here sin delta upon cos delta is tan delta. R get cancelled. We get again the same ratio. Divide by a1 cos phi 1 plus a2 cos phi 2, and delta can be written as tan inverse of the ratio is a1 sin phi 1 plus a2 sin phi 2, a1 cos phi 1 plus a2 cos phi 2. Now this equation we give the number it as equation 6. So here for the combination of two S.H.M.s, means the particle is subjected to two forces which alone can produce the displacement. Then resultant displacement is given by x is equal to r sin omega t plus delta. are related to A1, A2 and phi1, phi2 in this way, and delta also related to A1, phi1, A2, phi2 like this. So by using these relations we can obtain the initial phase. Delta represent initial phase of resultant S.H.M, and R indicates resultant amplitude of the S.H.M, resultant S.H.M, and X denotes the resultant displacement when the body is subjected to two forces. So this is the equations. These are 4, 5 and 6 are the equations for the combination of S.H.M.s we can use. Now there are 3 or 4 different cases which are related to the amplitude. We can here discuss those cases. How can we discuss? For that, simple calculations are there. So for case 1, if we consider phi1 minus phi2 is equal to 0, means the phase difference is 0, then R can be equal to A1 square plus A2 square plus twice A1 A2 and here cos 0, and you know cos 0 is 1. So we get A1 square plus A2 square plus twice A1 A2, and this is the expansion of A1 plus A2 square. So it is addition of both the amplitudes. Now the second case is related to again the angle, which is phi1 minus phi2 is pi radian. Then the simple case again we write A1 square plus A2 square plus twice A1 A2 and cos pi. Here cos pi is equal to minus 1. Here we substitute as minus 1. Here clearly I can write which is minus 1. So here R is equal to under root A1 minus A2 whole square by adjusting this minus 1 here. So R is equal to A1 minus A2. So if the phase difference between two S.H.M.s is pi radian, then resultant amplitude is the difference of two amplitudes. Here it can be taken as A1 minus A2, or here it is A1 minus A2 or A2 minus A1. Now the third case, we take it as 90 degree or pi by 2 radian. Then after substitution we get here cos 90. We get R is equal to under root A1 square plus A2 square plus 0. Cos 90 is 0. Therefore R is equal to under root A1 square plus A2 square. So such calculations we can make for the given conditions. So these are called as cases of the combination of S.H.M.s. So today we have discussed one long answer question, and also there are some short answer questions in this simple composition of two S.H.M.s. So you have to prepare those questions, as well as so many MCQs are based on this topic. You have to prepare MCQs also. So today we'll stop here. Thank you.